Today we are going to look at excess calculations. When we perform reactions, we often don't have the exact moles of each reactant required. More often than not, one of our reactants is in excess, meaning that we have more of it than we need, and the other limits how much product we can make, so we call it our limiting reactant. Based on the data we have been given about a reaction, we can determine which reactant is limiting and which is in excess. We can then use that information to help us calculate the mass of the expected product. In this example, we have 6.5 grams of zinc added to 25 centimetres cubed of dilute sulfuric acid, concentration 2 moles per litre. The first thing that we have to do is write out our balanced equation. So we have zinc plus sulfuric acid, and that would produce zinc sulfate and hydrogen. Now, to start calculating out these excess questions, the first thing you have to do is calculate the number of moles of both of your reactants. So let's start with zinc. In this case, we are using our triangle. So our number of moles is mass divided by gram formula mass. The mass is given to you in the question is 6.5 grams of zinc, and you'll find the gram formula mass in your data book, 65.4. Once you've done that, you'll get 0.0993 and so on and so forth, and we can round that and we can say we've got 0.1 moles of zinc. Our next step then is to calculate the number of moles of sulfuric acid. This time we have the volume and the concentration of acid, so we're doing number of moles equals concentration times volume. Remember, your volume has to be in litres, so you have to divide it by 1,000 there. And you'll work out that you get 0.05 moles. Your second step now is to go back and look at your mole ratio. In our balanced equation, we can see that 1 mole of zinc will give us 1 mole, or it will react, with 1 mole of dilute sulfuric acid. We don't have 1 mole of zinc, what we have is 0.1 moles, and therefore we would need 0.1 moles of sulfuric acid. Okay, so this is what we need. However, we only have 0.05 moles of sulfuric acid. Therefore, our sulfuric acid is our limiting factor, and our zinc is then our excess reactant. In this example, you're asked to calculate the mass of sulfur dioxide produced when 1.26 grams of sodium sulfite is added to 50 centimetres cubed of dilute hydrochloric acid, concentration 2 moles per litre. So the first thing we have to do here is make sure that equation is balanced. So we can see here we need to put a big 2 here and a 2 here to balance our equation. Then we go back and we have to again act like it's an excess question. So our first step is calculating the moles of our reactants. So if we start with our sodium sulfite, number of moles equals the mass divided by the gram formula mass. Our mass here is 1.26 grams, and we have to work out the gram formula mass. Sodium is 23, so 2 times 23 will give us 46. Sulfur is 32, we just have one of them. And oxygen is 16, and we've got 3 of them, so it's 48. If you add that all up, you get 126. back over, and 1.26 divided by 126, and that will give us 0.01 moles of sodium sulfite. If we then look at our second reactant, so we're looking at our hydrochloric acid, its number of moles equals concentration divided by, times by volume. Our concentration is at 2 moles per litre and our volume is 50 centimetres cubed. We need to convert that into litres, so be careful with that there. We then find our value to be 0.1 moles for that. Our second step is moving on to our mole ratio. So once you've done this, you go back and you look at our balanced equation. We can see that 1 mole of sodium sulfite will react with 2 moles of of hydrochloric acid. So it's a 1 to 2 ratio. If we have 0.01 moles of sodium sulfite, we would need 0.02 moles of hydrochloric acid. So we can see that this is what we need, and this here is what we have. We can clearly see then that the hydrochloric acid is in excess, and our sodium sulfite then must be our limiting reagent. What we now do is we use this number of moles of our limiting reagent to work out the mass of product that is needed. So let's move down. This time we're going to rewrite our equation. So we have our sodium sulfite, and what we're looking for is our sulfur dioxide. So 1 mole of this will give us 1 mole of sulfur dioxide. We actually only have 0.01 moles. So we will have 0.01 moles of sulfur dioxide. We can work out the mass that we actually have using the number of moles times the gram formula mass. Our number of moles is 0.01, and our gram formula mass we can calculate using our relative atomic masses. And that then will give us a final answer of 0.64 grams. So that's our final answer for this question.